Okay, the exercise 1a, z equal to fxy and is given the fxy is actually 3x minus y squared. Domain is actually input. Domain is the input, so the input is actually x and y. Range is actually the output, which is the z. Mean given the x and y, you map to z. So z is the range, x and y is the domain. Okay, so the question asks you to determine the domain and range of z equal to 3x minus y squared. Okay, so how to determine the domain? Okay, x here, 3 times x. You see x you can take positive value. Okay, you see x you can take positive. Okay, 0, negative. So, so x is actually a real number. Okay, do you understand what is real number or not? Okay, anyone?
No.
Real number. Okay, this is your x. And all the number in the in the what we call the number line here. It's not it's not 0. Okay, you see, -1, 0, 1. This is called integer. 2 negative. This is integer. Real number you may have floating point. Maybe 0 0.1, 2.2, 2. So this one, what we call real number. So real number can be positive, can be negative, can be positive, negative, 0, and you have a floating point. So real number. So 3x minus y squared, you see x here, you can have positive, negative, or 0. Or you see you have when you have function of one variable y equal to x. Okay, you sketch the graph of y equal to x. Sorry, here. This is x, this is y. So x is actually, when you have function of one variable, x is actually your domain. Okay, so domain, let's say put D. Okay, x can take up all the number in the number line here. So we said x is a member of real number. Okay, range. Okay, when x take when x is 0, y you get 0, x positive, y positive, x negative, y negative. So range is actually y. Y also real number. This is function of one variable. Now you have function of two variable where z depend on x and y, which is 3x minus y squared. Hence, x and y are your domain. So the domain, you have x and y. That x here is a real number. Okay, how about y squared? Y squared, this is actually when you break it, it's like you have z equal to 3x, z equal to negative y squared. Okay, then you can try to compare with function of one variable. Let's say y equal to negative. First of all, y equal to x squared. Okay, so this is a graph. Y equal to x squared, quadratic graph. Then you see the your domain is actually the x, and your x is actually in this case against x you see from the graph. Okay, negative part 0, positive part. Okay, that's why domain is actually domain for x is actually belong to real number. Okay, range is actually y value. Y, take up 0, right? Because when x 0, y 0. But y, you see from the graph, y is only 0 and up to positive infinity. Or you can say y is greater and equal to 0, where y is a member of real number. Okay, this is for y equal to positive x squared. If you have y equal to negative x squared, okay, because you multiply by negative, so your parabolic is flipped. Okay, so in this case, x still belong to real number, but the range of y is y less than and equal to 0. So domain still the same. Domain x belong to real number. Okay, the range is actually y less than or equal to 0, y where y is a member of real number. Okay, so this is for the case of function of one variable. You have now is function of two variables. So similarly, when you break this one, z equal to 3x minus y squared, you break it into z equal to 3x. It's like y equal to x, where the x take up all the real number, and then so if z equal to negative y squared, so y is actually like here, z equal to negative x squared. Your domain is real number. So in this case also y is a real number, because y squared, now y can take negative number, 0, positive number. That's why y is real number. So you see x real number, y also real number. That's why your domain is actually set of xy. So set xy is actually belong to real number. Okay, and then the range is actually the z. Okay, so you have real number minus a real number. Okay, so the range also is z should be real number. Okay, you can check 1a. Yeah. So this is how we find domain and range. Okay, for question 1a. Okay. So any questions here? Any questions? Okay, so find the domain and range, where the z is actually the third 2 minus x plus y. Okay, and then you have so to find the domain, when you have the square root function, domain and range must be real number only. You cannot be complex number. That's why to avoid you get the complex number, you have to set whatever inside square root is greater and equal to positive. That's why you set 2 minus x plus y greater and equal to 0. If you not set this one, later you have a square root, inside here you have a negative number, then it become complex number. So to avoid the complex number, we'll set 2 minus x plus y greater and equal to 0. That's why 2 is greater than x minus y. Okay, or x minus y less than or equal to 2. Okay, then if you want okay, you may have the domain, you can put out there. Okay, x minus y less than 2, or you want y as a title, then will be x minus 2 less than or equal to y, or y greater than equal to x minus 2. Okay, where the x and then I put up properly, the domain is actually y greater and equal to x minus 2, where x is belong to real number, y belong to real number. Okay, is it okay? Mean for square root function, always set whatever inside square root function greater and equal to 0. Then you may you want to stop here. Okay, you set this one, and then you can but we prefer y as a title lah, so we stop at this one. But if you give me this one, this one, this one, this one also can, no problem. Okay, so you obtain the domain. How about the range? Okay, square root here, actually we have positive or negative square root. Okay, if we didn't see negative, mean this will be positive square root. Positive. Okay, and then 2 minus x plus y, minimum is 0, right? Mean you set here 2 minus x plus y, minimum is 0. So if you have a square root 0, then you get 0. Okay, if you set this one greater than 0, the answer is positive. That's why your range is actually z greater and equal to 0, where z is a member of real number. Okay, so can you understand it? Okay,